I'm now moving on to ones that I think are hard that people didn't put down necessarily, but maybe we just didn't get to them yet. 15 spherical ball bearings are placed into a cylindrical container of cleaning solutions. If the base of the cylinder has a circumference of 4 pi and the fluid level rose 2.5 inches, then what is the volume of each ball bearing? Okay, so I think this is kind of hard. There's a lot of steps to this one. Excuse me. So, first of all, the cylinder the base of the cylinder has a circumference of 4 pi inches. We know that circumference equals 2 pi r, right? So then if the circumference is equal to 4 pi, then the radius must be equal to 2. This is important because now we can figure out the volume of the liquid, displaced, because we know that the liquid level rose 2.5 inches. So that means that the height of the displacement is going to be 2.5. So what we have is if we model the liquid that rose, we actually do get a cylinder, right? So this is just going to represent the liquid that rose after the ball bearings had replaced it. So this is the rising liquid. Okay, it has a height of 2.5 inches, right? And it has a radius of 2, as we discovered. So we can do pi r squared times height, pi times 2 squared times 2.5. Okay, that's going to give us the volume of the risen liquid. So we're going to do 4 pi, and if we want to be smart about this, right? So 2 squared is 4. 4 times 2.5 is just 10. So this is going to be 10 times pi, which should be about 31.4, right? So 31.415. Because it's 415, we're going to make it 31.41 or 4159. We're going to make this 31.416. Okay, so that's the volume of the liquid that was displaced. So that must equal the volume of the 15 spherical balls, right? A ball drops in, it raises the volume a little bit. A ball drops in, it raises the volume a little bit. We drop 15 of those in, it displaces a volume of 31.46. So the volume of each ball then is just 31.46 divided by 15. It's going to be about 2. Okay, we get we'll just call it 2.1. 2.1, and it's inches, so that's going to be inches cubed. That is the volume of each ball. If we drop 15 of these into the cylindrical cup, it's going to raise the liquid level by 2.5 inches. So your extension for this one is how much will the liquid rise if we drop that radius from 2, we're going to drop it down to 1.5. So that's your extension. If the radius is now 1.5 of the cylindrical cup, then how much will how high will the liquid raise when we drop the 15 balls in?